This video will show you how to do problem number 23 from chapter 8. So let me read this problem to you. You've analyzed a project using 4 scenarios with the results shown in that table below. Suppose you actually have 40 projects just like this one and that they pay off independently of one another. Find the probability that your average profit per project will be between $5 and $6 million. Alright, so I've already started doing a little bit of doodling here. So let's say we have a random variable x. So x is going to be the amount of money that we make from a single project. Now, we've been told the distribution of x, and so here it is off to the right. I've tried to sketch it, and so there's a 25% chance that we make $15 million. This is in millions of dollars. There's a 50% chance that we make $5 million. 15% chance we only make 2, and there's about a 10% chance that we lose $10 million. Okay, so for a single project, this describes what could happen. Now, we've been told that we actually have 40 of these. We're asked a question that doesn't make complete sense to me. I'm going to play with this in a minute, but let's go with it. Find the probability that the average profit per project. The reason is, what I really care about, I think, is how much money am I going to make this quarter, which would be a total rather than an average. But let's do what Siegel says. So, what is the average profit per project? Well, that's an X bar. So that's going to be the amount of profit we get from project 1 plus the amount of profit we get from project 2 plus all the way through the amount of money that we make from project number 40. And we're going to divide that by 40. So what we need to do is evaluate the probability that X bar is between 5 and 6. So we need to find, I'll just write it up here, probability that 5 is less than X bar is less than 6. Okay, so question is, what does the distribution of X bar look like? The distribution of X is surely not normal. It's kind of lumpy. Maybe it's a little bit left skewed. The central limit theorem is going to tell us something about the distribution of X bar, though. So here's the distribution of X bar. And it will be approximately normal, even though the distribution of X, the population distribution, is not normal. And it's going to have some mean that we're going to have to find and some standard deviation. So this is the sampling distribution of the mean. Now the question is, what does this mean? What is the standard deviation of this? Because if I know the mean and the standard deviation, then I can go do what I usually do to this. Well, remember that the expected value of X bar is mu sub X. So whatever the mean of this population distribution is, will be the same mean as that sampling distribution. And then the standard deviation of X bar will just be sigma sub X over root n. So that's root 40. So whatever the standard deviation of this distribution is, divide that by root 40 and we get the standard deviation of this. So how do we find the standard deviation and mean of this distribution? Well, we have to go back to the first section in chapter 7. Let's go over to Excel. And so we need to use Ed's table to find the mean and standard deviation. I've typed in that table. This is table 8.6.1 in the book. And remember that we always add a new row at the bottom that I call the sum row. Add a little bit of highlighting for that too. And the probability should sum to 1. If they don't sum to 1, we've done something wrong. So let's see, where is the sum function? I'll just type it in. So C2 through C5. And sure enough, they add to 1. So it looks like everything's good to go. Now to find the mean, what we're going to do is take x times the probability of x. So we're going to give this value minus 10 a weight of 10%. I'll do the other ones. So I formed that product. Let's copy that down. The value 5 is quite likely to occur. It gets half the weight, so we multiply by 1/2. The value 15 gets a fair amount of weight, not as much as 5. If we add these up, we get the mean. So the mean is 5.55. Let's go write that down. So the mean of x bar is the mean of x, which is 5.55. So here's the mean of the population distribution, which is also the mean of the sampling distribution of the mean. Let's go find the variance, which will get us to the standard deviation. So remember how we find the variance. We're going to take the probability times the squared deviation from the mean. So B2 minus the mean, which is $6. And we're going to square that. So that's how far minus 10 is from 5.55 weighted accordingly. So I'll copy this down, and then if I sum them up, I get the variance. But I don't want the variance, I want the standard deviation, so we have to take the square root of that number. So the standard deviation is 6.97, call it. So 6.97. 6.97. We could write that up here if we wanted to. Sigma sub x is 6.97. Divide by root 40. So this quotient is equal to 1.102. So let's go be consistent. We always write our standard deviations next to the distribution so that we don't lose track of them. All right, well now we're at a point where we can solve this problem. So we need to find the chance that the average profit per project, x bar, is between 5 and 6. So somewhere out here is 5. Somewhere over here is 6. I guess put it about here. And what we need is the area in the middle. So remember the table in the back of the book and norm dist in Excel only answer less than questions. So we'll evaluate that area, then we'll evaluate that area, and the little slice in the middle is what we actually want. So let's go write this out. This is going to be the same thing as me having a z, or at least approximately equal, because we have the central limit theorem here. Z is less than 6 minus the mean. Well, the mean is 5.55. Divide by the standard deviation. Which standard deviation? This one. So 1.102. Less the probability that I have a z less than, all right, 5 minus 5.55. Divide by 1.102. If you do your math, this is equal to 0.41, I believe. And this is equal to minus 0.50. So go look those two numbers up. And you'll get 0.6591 minus 0.3085. And that is equal to 0.3506. And that is the area in that tail. So that solves the problem. I'm going to add an optional part B. I said earlier that the profit per project is not as interesting to me as the total amount of profit that we're going to make in the quarter. So that's a t-hat problem. So let's say that t-hat is just the total of all the projects. That's an equal sign there. x1 plus x2 plus dot 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 x40. So how much do we expect to make over the period? Well, the expected value of t-hat is just n times mu sub x. So this is going to be 40 times 5.55, which is equal to 222. So we expect to make 222 million this quarter. What's the standard deviation of t hat? The t hat. Well, this is just going to be sigma sub x times the square root of n. So sigma sub x we found to be 6.97 times the square root of 40. So the standard deviation is 44.07. Now we could use this to answer various questions like what's the probability we have a really good quarter? Where a really good quarter is one where we make more than 300 million. So what's the probability that t hat is greater than 300? It's a greater than right there. Well, using our central limit theorem, this is just going to be approximately equal to the chance that I have a z greater than 300 minus the mean. Well, the mean is 222. Divide by the standard deviation, 44.07. And this is 1.77. We go look that up, and we get a 3.84% chance of having a really good quarter where we make over $300 million that quarter. So again, this was an optional part B, just showing how you could deal with totals as well.